Our topic here is about hyperbola. At the end of the lesson, you will be able to define hyperbola and determine the equation of a hyperbola. Let's have the definition of hyperbola. It says here that a hyperbola is a set of all points P whose distances from two fixed points f sub 1 and f sub 2 differ by a certain constant. Let us consider an illustration. The two red curves represent the graph of hyperbola, and a point P with coordinates x, y is on the curve. The absolute value of the difference of the distances from the fixed point f sub 1 to P and from the fixed point f sub 2 to P is 2a. Any point on the curves will always give a constant 2a when we take the absolute value of the difference of the distance of that certain point from the foci. We need to be mindful of the terminologies and properties of hyperbola. We have the following terms: foci, center, vertices, asymptotes, transverse axis, and conjugate axis. The foci are the two fixed points f sub 1 and f sub 2. The center is the midpoint between the foci, denoted by capital letter C. The vertices v sub 1 and v sub 2 are the points on the hyperbola collinear with the center and the foci. The asymptotes are the two intersecting lines passing through the center, which serve as the guide in graphing the hyperbola. The curves of the hyperbola will smoothly go nearer to the asymptotes, but will never pass through it. The transverse axis is a line segment with endpoints f sub 1 and f sub 2. The conjugate axis is a line segment perpendicular bisector to the transverse axis. The distance from the center to a vertex is denoted by A. The distance from the center to an endpoint of a conjugate axis is denoted by B. The distance from the center to a focus is denoted by C. And the square of C is always equal to the sum of the square of A and the square of B. An auxiliary rectangle is formed to aid in sketching the asymptotes. The sides of the rectangle passes through the vertices and through the endpoints of the conjugate axis. Let's have the equation of a hyperbola. There are two standard forms of the equation of a hyperbola with center at 0, 0. First, we have x squared over a squared minus y squared over b squared equals 1, and the other is y squared over a squared minus x squared over b squared equals 1. Observe the equations. There are two terms on the left side of the equation. The first term is positive, and the second term is negative. A squared is in the positive term, and b squared is in the negative term. If a squared is a denominator of x squared, then the transverse axis is a horizontal line, with equation y equals 0, and its conjugate axis is a vertical line with equation x equals 0. If a squared is a denominator of y squared, then the transverse axis is a vertical line with the equation x equals 0, and its conjugate axis is a horizontal line with equation y equals 0. The standard form of the equation of the hyperbola with center at k are given in the following forms: the square of the quantity x minus h over a squared minus the square of the quantity y minus k over b squared equals 1. And the other is the square of the quantity y minus k over a squared minus the square of the quantity x minus h over b squared equals 1. Still, we will be using the values of a squared and b squared to determine which equation will be used and how the hyperbola will be illustrated. Let's have some examples. Example number 1. X squared over 16 minus y squared over 20 is equal to 1. The equation has the positive term x squared over 16. The numerator has the x variable, so the transverse axis is along the x-axis. That is a horizontal line with y equals 0 as its equation. Since the transverse axis is a horizontal line, so the hyperbola opens to the left and to the right. The denominator of the positive term is 16, so the value of a squared is 16, and the value of b squared is 20. A is equal to 4, b is approximately equal to 4.5, and c is equal to 6. The equation of the asymptotes can be determined by replacing 1 in the standard equation by 0. The graph shows the corresponding distances from the center to a vertex is 4 units. From the center to an endpoint of the conjugate axis is approximately equal to 4.5. From the center to a focus is 6 units. Example number 2. The square of the quantity y plus 2 over 25 minus the square of the quantity x minus 7 over 9 equals 1. Take note that the equation has the positive term, the square of the quantity y plus 2 over 25. The numerator is y variable, so the transverse axis is parallel to y-axis. That is a vertical line with x equals h as its equation. Since the transverse axis is vertical line, then the hyperbola opens up and down. The denominator of the positive term is 25, so the value of a squared is 25 and the value of b squared is 9. The center of the hyperbola is at the point positive 7, negative 2. To find the value of c squared or c, we use the equation c squared equals a squared plus b squared. The value of c squared is 34, or c is approximately equal to 5.8. The distance from the center to a vertex is 5 units. The distance from the center to an endpoint of the conjugate axis is 3 units. The distance from the center to a focus is approximately equal to 6 units. The graph of the hyperbola is sketched through the aid of the asymptotes, which passes through the center and on the corners of the auxiliary rectangle. Example number 3. Find the equation in standard form of the hyperbola whose foci are f sub 1 with coordinates negative 4 square root of 2, 0, and f sub 2 with coordinates 4 square root of 2, 0, such that for any point on it, the absolute value of the difference of its distances from the foci is 8. Let us use the given conditions to make a rough illustration. The foci have coordinates on the x-axis, which leads us to conclude that the transverse axis is a horizontal line. So the standard equation that we will be using here is the equation x squared over a squared minus y squared over b squared equals 1. The distance from the center to a focus is 4 square root of 2. That is, the value of c is 4 square root of 2. For any point on the hyperbola, the absolute value of the difference of its distances from the foci is 8. So a is equal to 4. Using the equation c squared equals a squared plus b squared, we solve the value of b squared, and b squared is equal to 16. Hence, the standard form of the equation of the hyperbola is x squared over 16 minus y squared over 16 equals 1. Example number 4. A hyperbola has vertices on the points negative 4, negative 5 and negative 4, 9, and one of its foci is the point negative 4, 2 minus square root of 5. Find its standard equation. The given conditions will help us make a rough illustration. We plot first the vertices v sub 1 and v sub 2, and with it, By counting the number of units between v sub 1 and v sub 2, we can determine the center. The center is at the point -4, 2. With the given points of vertices, we can already determine which standard equation we are going to use. It will be the equation the square of the quantity y minus k over a squared minus the square of the quantity x minus h over b squared equals 1. One of the foci is the point -4, 2 minus square root of 65. This will direct us to see that the distance from the center to f sub 1 is the square root of 65, or c is equal to square root of 65. Using the values a equals 7 and c equals square root of 65, and the equation b squared equals c squared minus a squared, we can solve for b squared, and we have b squared equals 16. Therefore, the standard form of the equation of the hyperbola is the square of the quantity y minus 2 over 49 minus the square of the quantity x plus 4 over 16 equals 1. If the standard equation of hyperbola is transformed by expanding the parentheses and collecting terms with integral coefficients, then we are transforming the standard equation to general form. If the standard form of the equation of the hyperbola y minus 2 squared over 49 minus the square of the quantity x plus 4 over 16 equals 1 is transformed to general form, then we need to do the following. Expand the quantities, multiply the equation by the LCD 49 and 16, and arrange the terms from highest degree to lowest degree. The general form of the equation of the hyperbola is 16y squared minus 49x squared minus 392x minus 64y minus 1504 equals 0. The general form of the equation of a hyperbola is generally represented by the equation ax squared plus cy squared plus dx plus ey plus f equals 0. Take note that the coefficients a and c have unlike signs. For practice and to explore solving problems on hyperbola, we have here 3 problems. If you have answers to these problems and queries to the lesson, just comment below and don't forget to subscribe. Thank you.